Now students, we are going to understand how to apply the Leibniz theorem with the help of some examples. So I've taken two very simple examples, y is equal to x cube into e raised to mx and y is equal to x square into sine 3x. Now I need to apply the Leibniz theorem. That means I want to find the nth derivative of these two functions using the Leibniz theorem. Now students, I know that the Leibniz theorem is applied for u into v. U and v are two functions of x. They are both different functions of x. So here I need to apply the Leibniz theorem for u into v. U into v. So it becomes very important to decide which function should be taken as u and which function should be taken as v. Students, this is the most important part of the Leibniz theorem, taking the decision of u and v. Students who understand which function should be taken as u and which function should be taken as v, and they know the Leibniz theorem conceptually, I am very sure that these students will definitely be able to solve any given question on the Leibniz theorem. So make sure that you understand this concept that I will teach you very properly. Decision of u and v. Students, there is one simple golden rule for deciding which function must be taken as u and which function must be taken as v, and the rule is one which vanishes will be taken as v for vanish, isn't it? The function whose derivative will vanish after few steps, that function will be taken as v. Observe carefully. Look at x cube. Start thinking about its derivative in your mind. The first derivative of x cube is going to be 3x square. The second derivative is going to be 6x. The next derivative is going to be 6 and the last derivative is going to be 0. Are you observing what has happened over here? X cube, you started the derivative. The first derivative came 3x square. The next derivative came 6x. The next derivative came 6 and the last derivative, as I said, the derivative of 6 is going to be 0. So are you observing that the derivative of x cube is vanishing? That means x cube will be taken as v. Likewise, the same thing is going to happen with x square. So by default, I can say all algebraic expressions, whenever you have anything with x to the power, that particular function must be usually selected as v, because after a few steps, its derivative is going to vanish. That's why that function must be taken as v. Further, you should take that function as u whose nth derivative is available in the standard list of formulas. Don't you have the nth derivative of sine bx plus c? Students, sine bx plus c, if I ask you to get the nth derivative, it is available, isn't it? Don't you also know the nth derivative of e raised to mx? So we have the nth derivatives of some standard functions. So those standard functions whose nth derivative is known to us will be taken as the first function u, because if you observe the Leibniz theorem, u into v rule, it says you take un and then you start descending the derivative by 1, isn't every single time. So you begin from un and then you keep on descending by 1 for the subsequent steps. And what happens to v? You keep on ascending its derivative. So un, that means you should know a function whose nth derivative is known to us. So that function is taken as u, and the function whose derivative is going to vanish after a few steps, that function should be taken as v. It is as simple as that. So students, I know if I take the very first question, that is y is equal to x cube into e raised to mx. I know which function is u and I know which function is now v here. So I'm going to correct the order over there. So I have the question y is equal to x cube into e raised to mx. So I know u is e raised to mx and v is x cube. So I write e raised to mx into x cube. Now you need to remember your Leibniz theorem very properly over here. So I know yn is given by, I will write here, by the Leibniz theorem I can say yn becomes equal to what? It simply gives me un into v plus n into un minus 1 v1 plus n minus 1 upon 2 factorial un minus 2 v2 plus n minus 1 n minus 2 upon 3 factorial un minus 3 v3 and so on. We'll keep on coming till the last term, which is u into vn, isn't it? So that's the Leibniz theorem. It's very simple. Take u, keep on differentiating right from n, and you keep on descending its order, isn't it, by 1 every single time in the subsequent steps. Take v and you keep on ascending its order by 1 every subsequent step, v, v1, v2 and so on. So here I know that this is u, e raised to mx is taken as u, and this x cube is taken as v. So students, let's get yn very quickly. So therefore I can say yn is going to be un, that means the nth derivative of e raised to mx. So you must be recalling the nth derivative of e raised to mx. It simply says, if you have say e raised to x, its nth derivative will come e raised to x, and if you have e raised to mx, you get m raised to n e raised to mx, isn't it? So I get m raised to n into e raised to mx, that's un, into v. What is v? It is x cube. Then plus, you write n, you descend the derivative by 1. So it simply is replacing n by n minus 1, nothing else you have to do. Replacing un with un minus 1, it simply means what? You simply replace n with n minus 1 in the nth derivative. It is as simple as that. So if you want to keep on getting the subsequent derivatives, the nth derivatives, the n minus 1, the n minus second and so on, you simply keep on replacing n with that particular value. So you get this n according to the formula. The formula contains n, so I write n over here. Then un minus 1. So what is un that you know? This is un, isn't it? So wherever you see n, you simply replace it with n minus 1. That will give us the n minus 1th order derivative of u. So I get m raised to n minus 1 into e raised to mx, and now you get the first derivative, the first order derivative of v1. That means you now need to differentiate your function x cube. What is the derivative of x cube? It is going to be 3x squared. Then plus, you write n minus 1 upon 2 factorial. Again you want to descend the derivative of u again by 1. So it is now going to be n minus 2. So you simply replace n with n minus 2. That's all you need to do. So I get m raised to n minus 2 e raised to mx. So that's the n minus second derivative of u. So now again you want to differentiate your next function 3x square. v2 stands for what? It is the derivative of v1. So you had 3x square. Its derivative is going to become 6x. Let's proceed further. Plus n minus 1, n minus 2 upon 3 factorial, m raised to n minus 3. You get e raised to mx, and the next derivative of 6x is going to be 6, isn't it? No need to proceed further because the next derivative of 6 is going to be 0. Whatever the derivative comes here, you multiply it with 0, the answer is going to be ultimately 0. So now I don't need to proceed any further. This is my last step. Now students, if it is possible for us to simplify, we can simplify. For instance, this 2 factorial is 2. So this 2 and this 6 can be cancelled. This 2 factorial, which is 2, and this 6 can be cancelled, and you get 3. So you can write that 3 over there. This 3 factorial is actually 6. 3 into 2 into 1, that's 6. So this 3 factorial, which is 6, cancels with this 6, isn't it? So you can write one more step where you can simplify these terms and write the final answer. So isn't it very easy to apply the Leibniz theorem and then to decide which function should be taken as u and which function should be taken as v? Let's take one more example, a second example also, so that our concept becomes rock solid in our mind. So let's take the second function now. So we have y is equal to x square into sine 3x. Now you already know which function is going to be u and which function is going to be v. You know the nth derivative of sine ax plus b, or I can say sine bx plus c, whatever you say, and then x square, the third derivative is going to be 0, isn't it? The third derivative is going to be 0, so it is vanishing. So this must be v, this must be u. So let's correct the order. So I'm going to write sine 3x into x square. So let's very quickly get yn. You already have written the formula, isn't it? The Leibniz theorem formula is already written on the board over here. I'm just going to utilize this particular step. So yn comes equal to what? Un into v. Un, that means the nth derivative of sine 3x, it is sine bx plus c. So, or you can say sine ax plus b. Then the nth derivative is a raised to n sine ax plus b plus n pi by 2, isn't it? So here the nth derivative of sine 3x is going to be what? It is going to be 3 raised to n into sine of n pi by 2 plus 3x. So that's the nth derivative of sine 3x, because I have taken sine 3x as u, and I'm going to take this x square function as v. So now students, v is going to be written as it is. So I write here x square, isn't it? So that's nth derivative of u and the first function as it is. Then I write plus n into, you want to descend the derivative of u by 1. So what you simply do, go to n and you replace n with n minus n. That's all you must be doing. Nothing extra you have to do. So this is the nth derivative. This is the nth derivative of u. So what you need to do, just go replace n with n minus 1. So I get 3 raised to n minus 1 into sine of n, we'll write it n minus 1 pi by 2 plus 3x, and the derivative of x square, the first derivative. See, now you need to now start differentiating v, isn't it? So initially you write v as it is. Now you're going to write v1, which is the first derivative of v. So x square, the first derivative is 2x. I proceed further. I write n minus 1 upon 2 factorial. These all terms that I'm writing over here, this n minus 1 upon 2 factorial, this n, they are the part of the formula itself. Look at this, n minus 1 upon 2 factorial. It is a part of the formula, so it has to be there into this particular step. And then un minus 2 stands for what? It stands for the n minus second derivative of u, which can simply be obtained by replacing n with n minus 2 in un. So you go to un, this is the derivative, isn't it? Un, the nth order derivative. Go here and you simply replace n with n minus 2. So you will be getting here 3 raised to n minus 2 into sine of n minus 2 pi by 2 plus 3x into the derivative of 2x is 2. There is absolute no need now to proceed further, because as soon as you go ahead, the next derivative of 2 is going to be 0. Whatever the derivative comes here, it multiplies with 0. The ultimate answer is going to be 0. And if you keep on proceeding further till nth derivative of 0, it is definitely going to come 0. So that means you have to stop, you have to terminate at this particular step itself. This is the nth derivative of x square into sine 3x. Isn't it a very simple task to make use of the Leibniz theorem while solving the question, students? Isn't it? So here we have understood the application of Leibniz theorem to some typical examples, isn't it? The examples were very simple, but then now we need to begin with some complex questions where you are going to find the nth order derivative of the given functions y. So students, let's proceed ahead with some more questions.